people have proved results which allow us to simplify the process of finding limits when we have some knowledge already. So for example, you can combine two functions, right, to make a new function. For example, if I have a function, say f of x is say 2x plus 3, right? And I have g of x as some other function, let's say x squared. And I know I can make a new function by combining these, right? Say h of x is f of x plus g of x, correct?
Yeah.
So I can, in this case, I'll get a new polynomial, x squared plus 2x plus 3. So we know that we can make new functions by combining some functions in different ways. You can multiply them, add them, subtract, divide, right? Or even compose them. But how can we use that for limits? So for example, I know that it has a limit, say limit x approaching say 3, f of x is, and what is this limit at 3? 9 again, right? I want to find this limit x approaches 3 of h of x. Right? So now there are some results, right, that we will go over. One of them says, if we know the limits of these functions that you're adding at the same x, approaching the same x, then this limit is just the sum of the limits, right? So this is just 9 plus 9. This is 18. I don't have to do from scratch, try to prove what h of x is and then what its limit is when x approaches 3. Right? It makes it easy for us to, if I know the limits for this and this, and I know how these functions are combined to give me a new function, I can find the limit for the new function. Like, let me write out some of these results. So limit of c times f of x, right? So if I multiply a function by some constant and x tends to some value is the same thing as c times the limit for this. Is a function given, right, f of x. And we have to find the limit as x approaches 3 for 5 times f of x. So what we're saying is there's a new function we are defining. G of x is 5 times f of x, correct? And I want to find the limit for g as x approaches 3. Right? So how can I find that? I know how I can find the limit for f of x. Right? I know how to find that. From the graph, I can read it. Right? So this result is saying it is simply 5 times that. Because g of x, if you plot, right, 3 will become 15, this 2 will become 10. Everything is scaled up 5 times. It is saying if you're trying to find the limit is also scaled up 5 times. So that limit is 2. So the function g of x is 5 times this function. Everything is 5 times, correct? 10. So same thing will be for division, right? If you divide a number, it is same as like multiplying by a fraction. So if I was in the same thing, let's say I want to do, right? If I'm doing this, this will be limit x tends to 3 f of x. The whole limit gets divided by the same thing. It's kind of like multiplying by 1/6, right? 2 over 6, which is 1/3. Suppose I create a function by adding two functions. Okay. So now in this case, what happens is that the limits get added. Okay, so they've given two functions here. And we want to find the limit at -3. 3, right? So what will be this limit? Okay, it's just 3 plus 2. You don't have to actually combine the two to make a new function and then find its limit, because you have this result which says you can just add the limits and it gives you the result. So this also applies for subtraction. So same kind of thing applies when you multiply or divide functions. So if you're multiplying two functions to make a new function and you want to find the limit for that new function, and if you knew the limits for the original functions, you could just use those. Right? In this case, the limits get multiplied. But remember that there you're always approaching the same x position when we are talking about these results. It can't be like x approaching 3 here and x approaching 4 there. Okay. Okay, here we have two functions, f of x and g of x. And now we are multiplying those two functions to make a new function. And then we want to find the limit for that new function, which is f of x times g of x. What's the limit here at 2? 0, right? Because there's nothing special. It's just the value there. 2, right? It's approaching 2 from both sides. So this is the limit of f times limit of g. So 0 times 2 is 0. If one of them does not exist, then the whole thing does not exist. So remember that. Right? Let's say the limit for g does not exist, then the whole thing doesn't, because you cannot multiply something that does not exist. So remember that. As long as both limits are there, then you will get a result. But if one of them does not exist, then the whole thing does not exist. Similarly for division. But this second limit cannot be 0, right? Then it won't work. When the second limit is not 0, then that's what the limit is. So this would be the limit of f divided by limit of g, right? As long as the denominator is not 0. So what's the limit of f at 1, approaching 1? It has to be the same from both sides. Otherwise, the limit does not exist. So this does not exist. If them does not exist, then the whole limit does not exist. Right? Or undefined, you can say undefined also. So if you have, let's say, one function, right? You give it x and it gives you g of x, correct? And I have another function f, and I pass this as input to f. Then what will I get out? F of g of x, correct? Because g of x became the input for the second one. So this is called a composition, f of g of x. So first x goes into g, then the output comes out as g of x, that goes into f, then the output comes out as f of g of x. So this is also written as f of g of x. Okay, both of these mean the same thing. So one thing you have to remember is that x is first going into g, not into f. Right? If you look at this notation, you might think x first goes into f, then into g. No, x goes into g first. So this one is easier to understand. So we can compose functions to make new functions. And if that is happening, then what happens to the limit? So there are some results related to that can help us find the limits in an easier way. Say we want to find the limit of f of g of x when x is approaching a. Okay, and we also know the limit of g when x approaches a. So if limit of g of x as x approaches a, let's say it is known to be something, let's say b. And we also know that f is continuous at b. We will learn about continuity shortly, but what we can understand as continuous is if the graph looks unbroken, there is no hole or no asymptote. You could draw the graph without lifting the pen, for example, then it is continuous. At b means at a particular value of x. So if we know that limit of g of x at as x approaches a is b, some value b, and f is continuous at that value b, then we can use this result to find the limit. So limit f of g of x as x approaches a is f of b, which is same as f of limit of g of x as x approaches a. So this result can be used to find the limit of a composite function when these conditions are satisfied. So these are the two functions, f of x and g of x. And we want to create a new function by composing them, f of g of x, right? So if you remember the picture I drew earlier, and x is approaching 2, right? For finding the limit, we have to find this limit. Limit x approaching 2. So what is the limit of g as x approaches 2? 3, right? Because from here and from here, this is 3. Now, what does that mean? That 3 is going into f. What will come out here? F of 3, right? And f has to be continuous. As you can see, f is continuous. There are no breaks in f, right? Particularly at the value where we're looking at. What it is saying is we want to find the limit of this function. This whole function will not be defined at 2 because it's not defined at 2, right? If g is not defined at 2, nothing can go into f when x is 2, correct? G of 2 is not defined. But when we're taking the limit, that means we're close to g, either on this side or that side. That means we are close to 3. But if we are close to 3 here, we are approaching 2. So that limit is there. This whole thing is the limit. So suppose this whole thing I call h of x, right? H of x is f of g of x. So what is h of 2? I have to pass in 2 here, correct? Then g of 2 will come out. What is g of 2? There's a hole. So 2 is not even in the domain because it's not defined, right? So g of 2 is undefined, correct? That means f, you cannot find f because the input is undefined. So this whole thing is undefined, right? But what about the limit? Limit x going to 2 h of x. That's what we found out here, that the limit was 2. H is undefined at 2, but the limit of h near 2 is 2. Right? Because if you were close here on the left or right, you will end up close to 2 here on the left or right. So the limit is there. Okay, so we have to find the limit of h of gx. X approaches -1. Goes into g, then it goes into h, and then comes out the result. So if we have to find the limit of this whole thing, we have to find the limit of the first thing. Limit x approaches -1 for g. What is that limit? What is happening on g when x approaches -1? This -1, right? And that's the graph. So I'm approaching either from here or from here. What is the limit? 3. Because from both sides I'm approaching 3. So this limit is 3. That means 3 is going in here. What will come out? H of 3, correct? H of 3 is 1. So this whole limit is 1. What is H of G of -1? What is G of -1? 2. I'm not talking about limits now, right? I'm talking about the value. So this is H of 2. What is H of 2? This function H of G will be broken, correct? Because its value will be 2 there and then the limit will be 1. So same kind of thing, G of F, right? That means first we will go into what? First you have to go into F, right? Then it will give you F of X, which will go into G. And then I will get G of F of X, right? And I'm trying to find limit as X goes to 0 for this whole thing. So I have to find this first. Limit X goes to 0. So what is limit of F of X as X goes to 0? -1, it's going to -1 from both sides. So this is -1. So that means we will be getting -1 here. It will go into G, so then we'll get G of -1. What is G of -1? G of -1 is 4. It's continuous here. It's not continuous here, but at least wherever we are concerned, it's continuous there. So I can read up the value of G of -1, which is 4. So this is limit. This limit is 4. Instead of limit, if I try to find the actual value, G of F of 0, what is that? So F of 0 is the value at 0, and you see there is a hole. So it is undefined. So since once this becomes undefined, then we cannot find this out because we don't know what input is going into G. There is no input going into G. So this whole thing becomes undefined. So pay attention at each of these steps if you're finding the limit or you are reading the value. And if it's a hole or asymptote, then the function may be undefined there.